Applications: profit, revenue, and cost. So, to apply some of the things we've learned about derivatives and maximums and minimums and inflection points to various parts of your life, we're going to start with a business model. We're going to talk about how this might apply to economics. In order to do that, we have to have some common language to start talking about our functions. So let's talk about the three types of functions we're going to be looking at. First is the cost equation. The cost equation is written C of Q, where Q represents quantity. Now, the cost function is going to represent the amount of money it takes from the seller's perspective to make a product. So imagine that you're going to sell ceramic llamas. So the amount of money it takes you to make these llamas before you've sold them is your cost. Now, fixed cost is your cost before you've actually made any of these ceramic llamas. So these are your upfront costs. So maybe you buy the mold. Maybe you buy a building where you're going to produce these. Before you've actually made any of the product, you have these fixed costs. And again, that's the cost when you've made zero of your item. The next equation that we need to look at is revenue. So revenue is the amount of money that you take in from selling your product. The way that we calculate revenue is the price that you're selling your product for times quantity. So let's say you sell your ceramic llamas for $10 each. If you sell 5 of them, your revenue would be $50. So price times quantity. What's important here is that we remember that price is a constant and Q is your variable. Finally, we talk about profit. So profit we write as pi of Q. And profit is the amount of money you make by producing and selling an item. So your profit is your revenue minus your cost. So the amount of money you take in minus the amount of money that you spent. We're really hoping that profit is positive. However, as some business models will show you, sometimes you can have negative profit as well. So in relation to what we've been doing, there's some special terminology that we use when we talk about the derivatives of these functions. And when we talk about profit and revenue and cost, and we talk about the derivative, we're going to use the word marginal. So marginal in economics means that you're looking at the rate of change of the function. So when you talk about marginal cost, that's the derivative of cost. Marginal revenue is the derivative of revenue, and marginal profit is the derivative of profit. So now that we understand what these equations represent and the terminology, let's look at some ways that we can apply what we've learned in the earlier sections to figure out some interesting things about these functions. Example 1. Suppose the cost to produce an item is given by C of Q equals 10Q squared plus 1400, and the revenue is given by R of Q equals 4400Q. Now, there's a series of questions here that are going to represent all sorts of different things we can find out about these functions and about this particular model. So we're going to go through one by one, but I want to point out that it's the last 3 that really get into the derivatives and the things we've been applying them to so far in this section. So part A, how much does it cost to make 15 items? So that means we want to know what it's going to cost us to produce 15 of whatever it is that we're making. So that means that we're plugging 15 into our cost function. So wherever we see a Q, we're substituting in a 15. And then we're going to crunch all of these numbers together, and we get that it's going to cost us $3,650. So when we talk about cost and revenue and profit, we're always talking about money. So we're always going to talk about this in terms of dollars. So $3,650 is how much it costs us to produce 15 items. Part B, how much does each item cost when they are for sale? Now, the wording of this question is a little deceiving. You see the word cost here, but we're not talking about the cost function. When we ask how much does it cost when they are for sale, we're really looking for the price here. What is the price that we are selling this item for? Well, remember that price shows up as part of the revenue equation. revenue is price times quantity. So taking a peek at our revenue equation here, we have 4,400Q. So knowing that revenue is price times quantity, that means that my price here is $4,400. So whatever this item is that I'm making and selling, I'm selling it for $4,400. Part C. What is the profit function for this model? So remember, profit is going to be revenue minus cost. So that means here, I'm going to take my revenue equation minus my cost equation. Now, my revenue equation only has one term, 4,400Q. It's all one term, the two things multiplied together. However, my cost function has more than one term. So when I subtract it off, I'm going to use parentheses to make sure that my minus sign is distributed properly. So my revenue was 4,400Q minus cost, which is 10Q squared plus 1,400, and that gives me my profit function. Part D wants to know, what is the quantity that maximizes profit? So now we're into the part where we have to remember what it means to find a maximum. We know from before that maximums are going to happen at critical points or endpoints. We don't have an interval restriction here, so we're really looking for our critical points to try to determine if that's where we'll have our maximum. So if we want to maximize profit, we want to take the derivative of profit and find the critical point by setting it equal to 0. So here, when I take the derivative of profit, that's called marginal profit, I'm going to get 4,400 minus 20Q. Now, I want to know, when does that equal 0? So if I bring the 20Q over to the other side, and I divide both sides by 20, I get Q equals 220. So I have a critical point when my quantity is 220. But I want to be sure that I'm maximizing profit. If I accidentally minimize profit, that really wouldn't be good for business. So here, what I can do is if I check the second derivative of my profit function real quick, I notice that the 4,400 is a constant, so that goes to 0. And then the second term, I end up with minus 20. So I find that my second derivative is negative. If my second derivative is negative, that means that the entire original function is concave down, which means that my critical point has to be a maximum. So I'm in luck here. Q equals 220 has to be the maximum of this function. So that's the quantity that maximizes profit. Part E wants to know, what is the maximum profit that can be achieved? So now that I know when this maximum happens, Q equals 220, I want to know what the actual profit is. So I need to take that 220 and I need to plug it back in to the profit function, which is what we found in part C. So everywhere that there's a Q, I'm going to plug in a 220. And again, I'm being careful with the second part of the term, and I'm using my parentheses because that minus sign has to go to everything in the cost function. And when I plug this all in carefully, I get 482,600. And remember, all of these functions, cost, revenue, and profit, are all talking about money. So again, $482,600 is the maximum profit that can be achieved. So again, if I'm looking for the maximum of a function, even if it's a function I'm not really familiar with, I can use whatever function I have and use derivatives to find critical points, which are going to identify where maximums and minimums exist. Let's look at another.